Hi everyone, this is Nagajyoti working as an assistant professor in Department of ECE in St. Peter's Engineering College. So, we are dealing with a course of linear IC applications which completely deals with operational amplifier. So, in case of Unit 3, we are going to discuss about how to design a filter by using an op-amp circuit. So before going for the filter designing using op-amp, first of all we need to know what is meant by a filter. So filters are electronic circuits which will allow a certain frequency components and reject other frequency components, as it is allowing or selecting a particular frequency components. Filters are also called as frequency selective networks, and depending upon the elements which we are using in the filters, these filters may be either passive filters or active filters. So here the name itself indicates, in case of a passive filter, it consists of passive elements like R, L and C. But whereas in case of an active element, along with the passive elements, we'll be having an op-amp. So if we are having a passive filter, what is the need for using an active filter instead of a passive filter? So there is a limitation of a frequency range in a passive filter. So in order to avoid that limitation of frequency, we'll be using active filters, and active filters will give more stable than that of a passive filters. So let us discuss about the active filters classification. So active filters are classified into 4 different types depending upon which frequencies are going to be allowed and which frequencies are going to be rejected. The first one is active low pass filter, active high pass filter, band pass filter and band reject filter. So here the name itself indicates the low pass filter should have the capability to pass lower frequency components and reject higher frequency components. But how to know which frequencies are lower frequencies and which frequencies are higher frequencies? So in order to know the differentiation between those two, we know that the frequency is given by 1 by 2 pi RC, means depending upon the resistance and capacitances values, we'll be having a frequency. That frequency is called as a cutoff frequency. So some filters will allow greater than cutoff frequencies and some will allow less than cutoff frequencies. So depending upon that, we can classify whether the filter is low pass, high pass, band pass or a band reject or a band stop filter. So coming to the first one, low pass filter. So the name itself indicates it should pass the lower frequency components, that is less than the cutoff frequency and greater than the cutoff frequency value should be rejected. So if we are speaking ideally, there is no differentiation between stop band and a pass band. So here what is meant by a pass band is the band of frequencies which are allowable are called as pass band. The band of frequencies which are rejected by a filter are called as stop band. So in ideal case, there is no transition between pass band and stop band. But practically, there is some difference between these two bands, and such a band is called as transition band. So the variation of these transition band depend upon the type of the filter which we are using. So here type of the filter represents order of the filter. So if we observe this circuit diagram, as it is a low pass filter, in case of a low pass filter, input is given across the resistor and output is taken across the capacitor. So for the non-inverting terminal, input is resistor, output is a capacitor. So it is a low pass filter. So RA and CA acts as a low pass filter. These frequency components which are passed by these low pass are amplified by using an op amp. So if we perform same filtering concept by using a passive components, we won't get the output voltage greater than that of the input voltage, because it is just passing which frequencies need to be passed and which need to be rejected. It is not considering any factor of amplification. But in case of an active filters, as we are having an op amp over here, along with this filtering, it also performs the other more operation of amplification. So always in case of an active filters, the output voltage will be greater than that of input voltage. So the next type of filter is an high pass filter. So the name itself indicates it should pass high frequency components and it should reject the low frequency components. So if we interchange R and C elements of a low pass filter, then it is called as an high pass filter. So in order to prove this circuit as an high pass filter, we need to derive an expression in terms of an voltage gain, that is output voltage by input voltage. From that we'll be getting a cutoff frequency. Assume one time f is equivalent to cutoff frequency, and for the next time f is less than cutoff and f is greater than cutoff. So from that we can prove which frequencies are going to be attenuated and which are going to be passed. And in these circuits, as we are using only one RC combination, so these comes under first order filters. So here the name itself indicates, first order itself indicates it consists of only one RC element. So if we want to make our practical filter approximately equal to ideal filter, we need to use more number of RC sections. That is, if order of filter is increasing, the frequency response of a filter is approximately equal towards the ideal value. So this is a frequency and phase response of a high pass filter. So here FC represents a cutoff frequency. So the below cutoff frequencies are not going to be passed and above cutoff frequencies are going to be passed. So the band of frequencies for which the circuit is going to be passed are called as pass band, and rejected frequencies are called as stop band. So if we want to calculate the gain, always the gain should be calculated in terms of dB, that is 20 log of output voltage by input voltage. Similarly, in case of a phase plot, we need to find out at which point we are getting a maximum value of the corresponding magnitude. So here, if the frequencies are not passing through a filter, the phase value is maximum. As frequencies are passing, the phase is going to be decreased. So this is all about high pass filter. The next type is band pass filter. So if a filter allows certain band of frequencies and reject the remaining are called as band pass. So in case of a band pass filter, it lies between lower frequency range as well as higher frequency range. So here it need to pass certain range of frequencies between lower as well as higher. That is the reason in case of a band pass filter, instead of having single cutoff frequency, will be having two cutoff frequencies, that is FC1 and FC2. So the frequencies less than FC1 are rejected and greater than FC2 are also rejected. The frequencies which are in between FC1 and FC2 are passed. Such a filter is called as band pass filter. And in case of band pass filter, we need to remember a term called as Q factor. So here the Q factor specifies the quality of the filter. So depending upon this Q factor value, this band pass filter may be narrow band pass filter or wide band pass filter. If Q value is greater than 10, then it is called as wide band pass filter. If Q value is less than 10, such filter is called as narrow band pass filter. So here, in case of narrow band pass filter, the name itself indicates it should allow only a small range of frequencies. That is the reason it is called as narrow band pass filter. So this is the structure of a band pass filter. So as we know that a band pass filter should allow greater than FC1 and less than FC2. So here greater than FC1, greater itself indicates we need to use high pass filter, and less than cutoff frequency is low pass filter. So here if we are able to see this circuit from this, we can directly say that the first part is a high pass filter. The high pass filter output should be given as the input for the low pass filter. So the output of such filter is called as band pass filter. So in case of a band pass filter, high pass filter is passed through the low pass filter, which gives band pass. These are the frequency responses of a band pass filter, in which the pink shade represents the stop band. So here we are having two cutoff frequencies, one is FL and the other one is FH. The frequencies less than FL are rejected and greater than FH are also rejected. It is passing the frequencies between FL and FH. Wherever you are having maximum voltage gain, the corresponding phase should be equivalent to 0 degrees. And whenever the frequency response is increasing, the phase plot is going to be decreased. And similarly, if phase plot is decreasing, frequency response is going to be, that is just reverse to that. Last type of the filter is band reject filter. So here the name itself indicates it is quite opposite towards the band pass. That is, here we need to reject certain frequency components. Other than these rejected frequencies, all the remaining should be passed. That is, less than the lower cutoff frequency and greater than the higher cutoff frequency should be passed. Only between the cutoff frequencies it should be rejected. This band reject filter is also called as band stop filter, or it is also called as notch filter if Q value is lesser value. This is a first figure shows the block diagram of a band reject filter. That is, it should pass low frequency components and it should pass high frequency components. That is the reason here the same input is given to both the filters and the output of these two filters is given to a summing amplifier. So here low pass circuit, that is the first input should be a resistance, output should be a capacitance. Similarly, high pass input is capacitance, output is resistance. So we need to draw separately a low pass filter followed by an high pass filter. Both these filter inputs should be given to a common input and the output of these two should be connected to a summing amplifier which will perform an operation of addition of low pass filter followed by an high pass filter. This is the frequency and phase response of band reject filter. So here lower than cutoff frequencies are passed, higher than cutoff frequencies FH are passed, and it is rejecting the frequency components in between FL and FH. If this FL and FH value is very less, then it is also called as narrow band reject filter or a notch filter. So in all these filters, there is change of the frequency component. In certain frequency components are rejected and certain frequency components are passed. And we are having the other more filter called as all pass filter, in which the name itself indicates it is having the capability to pass all the frequency components, but there will be a change in the amplitude of the signal whenever it is passing through an all pass filter. So all pass filter will pass all the frequencies, but the amplitude difference between the frequencies can be calculated by using an all pass filter. This is all about the filters, and along with this we need to derive the voltage gain for each filter, and we need to prove which frequencies are going to be rejected and which frequencies are going to be passed mathematically. This is all about filters. Thank you.